Hello everyone, welcome to the Wheat Marketing Center. I am here with Jane today and we are going to look at a new scanning technology that you can use in your bakery to analyze your products. Alright, let me get my LinkedIn screen properly. If you have any questions, please type into the link in comment section and I should be able to answer your questions, okay? So sorry about this weird angle, but I wanted to keep it such so that I can actually show you what we are doing. All right, so the C-cell technology uses scanning and imaging to measure the porosity of your product. And the reason why I like using it is because it takes the subjectivity out of analysis, right? Say if you are increasing the pressure of a divider and to help with the openness of the crumb, and you have a problem in getting people to agree which divider pressure is better for the crumb, this is the instrumentation for it, okay? This is the instrumentation to erase any kind of bias or subjectivity, and it goes down to measuring the amount of cells, how big the cells are, and this is so important in terms of fine-tuning your process, okay? So we will let Jane take it from here, and I have two samples made up. The control sample, which is a straight dough, 3-hour, it's a 3-hour Polish fermentation, which is the control, and then a 4-hour Polish fermentation, which is the variable. So total fermentation difference in time is 1 hour, and I wanted to test to see if that opened up the porosity of the crumb, okay? Sorry about the mess, and you can't really see me talk, but we're adhering to, regulations here. And I'm going to be behind the camera, so Jane's going to be in front, and I can see all your comments, so put all your comments in there, okay? All right. Jane, before we start instrumentation, what do we need to do with this?
In what sense?
The whole thing. How's the setup like? What do we need to do the first thing?
So the first thing we're going to do is we're going to calibrate the C-cell. I have this calibration placard right here that I'll put in there. It has two sides to it. And so we start with this gray side. We let the instrument calibrate itself versus that. And then we put the gray scale slide up, and we'll let the instrument calibrate against that as well.
Okay. So how long is this calibration?
So on average, this calibration is going to be 60 seconds or so.
Oh, that's fast.
It's a really fast process.
Just a click of a button.
Yeah, and so you can see here that there's a light on in there, and once we start the actual calibration process, you get different light sources coming on.
Ooh, this is what's happening
Yeah.
inside. You're like taking pictures of that thing. Ooh, calibrating. Okay.
And so the first 4 stages of calibration will all be with the gray side of that placard. The 5th and final stage of calibration will be with that gray scale side of the placard.
Okay. All right. You know what I wish? For every instrumentation out there to be so quick in calibration. But I'm so glad that they have a calibration and they recommend calibration at the beginning of every test. And it's so easy to do. All right.
So it's done with the first 4 stages. We just need to flip the placard. So I'm just flipping it over to the grayscale side, closing the drawer again, and it's already finished.
Ah, got it.
Very fast.
Yeah. So I have a question for you in terms of lighting in here. Does lighting actually affect the test?
So in terms of our ability to visually score, absolutely, the lighting will affect the outcome.
Yeah, that's
But
lighting.
in terms of the C-cell itself, all of the lighting that it needs is internal, so none of the outside or ambient lighting is going to impact what the C-cell measures because it's all self-contained.
Okay.
So let's
Sounds
test
great.
the first sample.
All right, first sample. Control sample. 3-hour pulish.
And so what Lynn's done here is she's cut horizontally, because as you can see, it's not a very, very tall loaf.
Yeah.
Which kind of minimizes that slice area.
Yeah,
So-
and I wanted to get more surface area. That's why I did it that way rather than one slice by one slice.
Yeah, and since this top is domed, it creates an uneven, potentially an uneven surface for scanning and imaging. So we're going to use this bottom half because it's really nice and flat, and you can get a really nice level surface for that imaging.
Okay.
So once you put the sample in, you can see on the screen if you've got it properly centered or not. Obviously, this is a pretty big piece. It doesn't quite fit within the entire imaging area, but this is for demonstration purposes. But ideally, you'd have it entirely within the frame. And so I'm just going to create a batch real quick. We'll just call this control. And we'll go ahead and analyze the image.
Interesting. Put it right here. Let me see if I can get a spot on here so that I can have free hands to write the sample.
And it looks like you've got a little bit of a communication error.
Uh-oh.
So what we're going to have to go ahead and do.
Things happen in
Yeah.
live streams.
So we're just going to exit out of the program real quick. And we'll go ahead and we'll do the calibration process
Move
again.
away.
This is not unusual. We have slightly older computers.
Yeah, I think the interface has a
Yeah.
lot to do with the connectivity.
So it's nothing about the instrument itself.
Right.
It's
So you can't really use the instrument without a computer. It has to be attached to a computer.
correct.
Okay.
Yeah, because all of that imaging analysis requires a lot of complex algorithms and whatnot. So you really have to have the software in order to do that detailed, objective measurement of all the cells in the slice. And luckily, the calibration process is so fast that it's not a big deal for us to have to close down the software and recalibrate.
Right. So what do you do here at the Wheat Marketing Center, Jane?
Staying busy with new crop quality.
Oh, yeah. What do you do with the new crop quality? You generate analysis of crop from the Pacific Northwest, or?
Yeah, so we characterize the crop quality coming out of the P&W,
Uh-huh.
but we also characterize the quality of the soft white and hard white wheat classes across the nation.
Oh, interesting.
And all of that data goes into the U.S. Wheat Associates annual crop quality survey.
Ah, that's a lot of work.
Yeah.
Yeah,
So
it's a
there
lot of
are-
data.
There are other institutes that do the other wheat classes. We just do the white wheat classes.
Yeah, interesting.
Batch again. There we go. So you can see that the light source has kicked on and the image changes.
Ah, I see. Okay.
And so now the program is basically scanning the slice and running through all the different calculations, and it'll put out a report here.
Ooh, this is interesting. What do we have here?
So there are several different ways of looking at the data,
Uh-huh.
and some of those are the actual images that the
Sorry.
the
I'm just gonna move this in front. Oops. Yeah.
So several different ways of looking at the image itself. So this is the original image.
Mm-hmm.
You can look at it in more of a grayscale.
Okay.
But then you can also get into the cell scale, and so you can
Nice.
start to see a breakdown
Okay.
of where the cells are. you can start to see, so these red areas are where you tend to get more coarse or open cells. The
Oh,
blue
this is
areas-
so interesting. What is the
Yeah.
difference in the contrast?
In the contrast?
Yeah, what is the difference between the red and the blue?
So yeah, the red areas mark areas where you're tending to see larger or coarser cells. The blue areas are where you have a little bit finer or more closed areas, smaller cells. And so there are different ways, and there are lots of different images here that you can use in terms of just visualizing where are coarse versus fine cells, and how are they distributed, and does that make a difference for your product or not.
Okay.
But if you want to really get into the details, you can actually break it down to numeric form. And so you can look at things like the color of the slice, things with dimension, and the shape. But if you're really interested in crumb structure,
Yep.
you're going to be spending a little bit more time, especially in the cell size area, and possibly in elongation, depending on the type of product that you're working with.
All right, so what do you recommend for us to really look at for this particular exercise? I want to check out, okay, does fermentation increase the holes in my bread? What should we be looking at?
So obviously you can look at any of these parameters. Some that I tend to look at would be number of cells. So obviously if you have a lot of smaller gas cells,
Number of cells is the first one.
yeah.
Yeah.
If you have a large number of small gas cells versus a smaller number of large gas cells, obviously that shows up in the number. You can also look at things like cell diameter, and you can look at cell volume.
Cell diameter. I'm writing this down to
Yeah.
see what's the difference with the next one. And what else? Cell volume?
Cell volume.
Okay.
You can also look at something called coarse cell volume,
Course.
which should tell you more information about how much area or how much volume that your coarse cells are. taking up.
Interesting. Okay.
And if what you're concerned about is more uniformity, you can also look at something like the non-uniformity here, or the coarse to fine clustering ratios. It all depends on the product.
Okay. Sounds good.
So those are just a few numbers that you could look at.
All right. Hey, Paul's online. Hi, Paul. Say hi, Paul. All right. So, let's go into our next sample. So we have.
It's going to be a bit of a pain again.
Gotta get a new computer.
I know.
Oprah says, super exciting, fascinating. Here is Jane introducing the world to measuring holes in bread. We all need a tool like that. If there's any issues with your computer interface, all you really need to do is just easily calibrate it again before you carry on your next sample, so that it's standardized across calibration.
Yeah, and normally we don't tend to have this many communication issues, but because we're live streaming,
Yeah.
it's that paradox.
Yeah, it is. A lot of things like to happen on live streams, as I can attest to. If it's a mistake, it always happens. All right, so how big is your team over here, and how many samples do you guys actually run through the lab during harvest?
So we have a team of 6, but as far as active people who are active in the lab, we're relying primarily on a team of 4, and one of those is a crop quality intern. And so, yeah, during the initial phases of harvest, we'll rely on that team of 4. And then as we get into the U.S. wheat crop quality survey aspect, we're actually making end products with the new crop wheat, that effort will expand to include myself and our food scientist on staff. So we'll have a full 5 to 6 members working on making all those end products and then evaluating them.
Wow. You
Yeah.
actually make end products for
Yeah.
evaluation. So how many Pablos or cakes is that? Thousands?
So what we do is we actually do composite samples instead of testing each sample individually.
Oh, good.
And so we break them into protein content ranges. And depending on which wheat class it is, we might have between 3 to 5 protein content classes. Typically not 5, but sometimes, just you've got the range, so you test it.
Interesting. Wow. All right.
So
Next
let's
one.
test the next
Let's
sample.
go with this one. 4-hour ferment.
Nice and centered. This is the 4-hour. And there we go.
Let's hope this time will give us a report. Oh, look at that. That's a huge difference in that area.
Yeah. So you look here.
Yeah. Okay.
And you can look at this scale as well, and you can see there's a lot of lighter colored blue on this particular scan compared to the last loaf. So that tends to indicate you've got some coarser cells in there. If we look at the crumb data, the number of cells has certainly dropped.
Number of cells was 10,882. Now it's 10,459. Just a little bit though. Is there anything
Yeah.
else that really shows?
Let's see, number of holes.
Number of holes previously was 3.08. Now that's significant. Now it's 1.03.
And so
Okay.
the area, where do we have? So the area of the cells is 53.8.
Okay.
So that's gone up slightly.
Mm-hmm.
And cell diameter,
Wow, that one really went up.
yeah, so the diameter of the cells is increasing, which is a good indicator that you're getting larger, more open crumb structures.
Yeah, so it went from 1.75 to 2.25. Okay.
So cell volume is 27 now.
Versus 21 just now, so that's a great indicator as well.
And then coarse cell volume is 12.04.
Yep, that is a huge difference as well. So I think for all of future examination and to open up the crumb structure, we should be, correct me if I'm wrong, looking at cell diameters, cell volume, and coarse cell volume.
Yeah, and like I said, you can pull a whole lot more information out. There's a lot of information here. These are just some quick areas to look at, but definitely don't ignore the rest of the data that's
Right.
being put out.
Right now, this is also interesting because it shows you where the cluster is in terms of how big the cells are, you know.
Right.
Yeah, absolutely. So let me ask you, can this all be imported into an Excel spreadsheet?
We can actually print this as a PDF.
Okay.
You should be able to do a quick copy and paste into
Oh,
an
interesting.
Excel
Oh, nice.
spreadsheet.
Okay. Okay.
It's however you want the data presented. We usually just print off the PDF, but yeah, you can definitely put it into a spreadsheet and do some side-by-side comparisons that way.
All right, thanks. Okay, folks, so you have seen firsthand on, let me get in front of the camera, on how the C-cell works. And if you have any more questions, you can contact Stephen Pike at C-Cell, and you can get their information from our sponsor showcase on Bakerpedia.com. okay? If you want a quote on this instrumentation, or you would like to test it out, give them a call, okay? So I want to remind you of one more thing. These cool t-shirts are available on bakerpedia.com. Okay, this one's specifically about flour. Okay, you need to get it. So I'm going to be back again next week, and we will be talking about, back as in life. We'll be talking about shelf life of bread products for one of our seminars. So please sign up today at bakerpedia.com/academy. Okay? So thank you for joining me today, and thank you, Dr. Jane, for letting me come to the lab and checking it out. All right, so see you tomorrow.